We are now in the question number 17. This is a two-part question. The first part is to find the derivative of a function at a given point. It's very simple. The second part, that is to graph, the derivatives. Now, they will ask you either to graph the derivative or the derivative will be given and we have to graph the function. We'll look into all the type of problems here. The first one, which is, see now, one more thing I want to tell you. When we go for corrections, they will specify us, it doesn't matter which method is used, as long it is in writing and in proper method, and you're getting the exact answer, you will get the full marks itself. So now over here, in the solution set, they have specified to use this formula and solve. You might know this derivative formula, and then we use it and then we simplify and finally find the answer. This is possible, but even if you use the power rule, you should technically get the full marks. But I will do both the methods. I think so. Over here they have used this formula, but there's one more formula. Let me just check. Yeah, this one, the slope formula. We will look into all these in a while. Now let's use this method and then solve. What does this method specify exactly? Now you might know what is exactly slope. I mean the derivative. Derivative is the slope of the tangent line. How do we find slope? Imagine this is the curve. We need to find the slope from year to year. We need at least 2 points, x1, y1, x2, y2. Is it possible to find only at x1, only at one particular point like this, only at this point? Is it possible? No. But I can do one thing. Instead of taking the point so far away, I will take it very, very near. Okay. This is x1, y1. This distance, the next point is x1 plus h. Very close. Now what we do is we will get 2 points. We can substitute over here and solve. And then we are taking the limit of this h to 0. That means this point is infinitesimally close to this particular point. It's basically almost that same point. Okay, so close. That is the concept behind this formula. Now this is the main details of it. Now if you just see this formula, direct substitution and then solving it, basically nothing much over here. How do you do this is, say, okay, we need to first, we have f of x given. Okay, f of x is there, equals 3x cubed plus 2x minus 1. What is f of x plus h? Here, wherever x is, they put plus h. That's it. 3, it becomes x plus h the whole cube, plus 2 into x plus h minus 1. Okay, it will be minus 1. This is the x of h. H remains as it is. We will take the limit of 0. It will be dissolved. So now here, let's do the substitutions. The limit as h tends to 0. What is f of x plus h? Let's try to be more straight. Okay. It's 3 of x plus h the whole cube plus 2 of x plus h minus 1 minus, what is f of x? 3x cubed plus 2x minus 1 divided by h. Now, I will be really honest with you. I did this just a while ago. I have deleted that part. Why? Because I forgot to multiply this minus sign throughout. I did everything right, but this minus, I just multiplied for 3x cubed because I had not used this brackets. I was just writing it and I forgot to minus. I multiplied the minus and it went all wrong. So please be careful. The signs are very important. If you miss the sign, then you will get wrong answer. Now here we can't directly solve it. You need to use the identity, that is a plus b the whole cube. I hope you remember that's a cube plus b cube plus 3a squared b plus 3ab squared. Okay, and then now we just do the substitution again. Limit h tends to 0. 3 multiplied by what? Ax plus h the whole cube will be x cube plus h cube plus 3x square h plus 3xh square plus this multiplied inside will be 2x plus 2h minus 1 minus 3x cubed minus 2x plus 1. It's direct substitution, algebraic substitutions, divided by h. Now again you have to multiply this 3. So we'll do that in step itself. Limit as h tends to 0. It'll be 3x cubed plus 3h cubed plus 9x squared h plus 3x, oh sorry, it's 9 over here, okay? 9x h squared plus 2x plus 2h minus 1 minus 3x cubed minus 2x plus 1. Then divide this by h. Now we can see some terms get cancelled. That's 3x cubed minus 2x and 2x plus 1 minus 1. What else? Let's write the remaining terms. It is limit as h tends to 0. What is remaining? It's 3h cubed plus 9x squared h plus 9xh squared plus 2h 2h plus 1 divided by h. Sorry, what am I writing? There's no plus 1. My bad. Now, this is the thing. Now here, what you need to do is divide h throughout. It will be limit as h tends to 0. That will be 3h cubed divided by h is 3h square. I'm writing it directly. Plus 9x square, h and h cancels. Plus 9xh because h square and h cancels. Plus 2, h cancels. Now apply the limit. What happens when you apply the limit? This will be 3 times 0 plus 9x squared plus 9x of 0 plus 2. This technically will be, this is the substitution over here. Sorry, this is 2. And now all the, wherever the h is there, they become 0. So you can directly write whatever is non-h part. That is 9x squared plus 2. That's it. This is the derivative. We did all this formula just to get this answer. Now I will tell you how you can directly get this as well by power rule. We know this 3 comes down, isn't it? So we have over here, let's derive f dash of x will be equal to 3 comes down will be 9x, 3 minus 1 is 2 plus 2, the constant is 0. The same answer. But this is the actual formula to get the derivative. This is the power rule, the derivation, the simpler versions. Now over here, if you want to find x1, see this also can be done. Now x1, what happens? Just substitute 1 over here. I'll write it over here. 9 into 1 the whole square plus 2. If it's 2, 9 into 2 the whole square plus 2. And lastly 3, 9 into 3 the whole square plus 2. So it's just substitute the values, and in the calculator you can do it. Now 1 square is 1, 9 plus 2 is 11, 4 times 9 is 36, 36 plus 2 is 38, 9 squared 9, 9 is 81, 81 plus 2 is 83. So these will be the final answer, 11, 38 and 83. So let's just check the answer. It's 11, 38 and 83. That's how we solve it. Over here the detailed method is also there. You can just refer to this. So this is the actual method of deriving. This is without the power rule, by directly the formula. There are more problems on this. Please do solve them by yourselves. These are simple problems. Here you can see now, if you're directly deriving it, what's going to be the answer? It's just 3. Answer is 3. Doesn't matter what 3. Why? 3 into x will be only 3. But here both the formulas are used. That is the first one. Now here they have taken f of 1. I'll write the formula first. 1 second. The formula is, for this part we just did, limit as h tends to 0. It is f of whatever is this a or x. I'll write it as a because it's given as a plus h minus f of a divided by h. Here it is basically f of b minus f of a divided by b minus a. But now a value is 1, so they have substituted 1 and then solved it up. Okay, just like what we have done a while ago, direct substitution. Now, if the value is not of cube or squared, it's much simpler. You can see easily you can get the answer. Doesn't matter which formula you're using. They're using 2.1 formula and 2.2. This is first formula, second formula. You will get the same answer. They are same. Both are derivative because you're finding the slope of the derivative, right? Slope of the tangent line. That's the derivative basically. Even over here, it's the same concept. First formula, second formula, you'll get the answer. The steps are there. Please refer to the steps as well. And now, if you're thinking of the power rule, this 2 comes down, it'll be 2 times 3 is 6x. That's the answer. Now, what is the a value? It's 1. So 6x is 6 times 1, that's 6. Here, you can do the same thing. It'll be long, but if you're doing the power rule, I will just do it. Then you can refer the formula methods. The power rule over here, we know root x derivative is 1 by 2 root x. So I'll directly apply that. 1 by 2 root of 3x plus 1 multiplied by the chain rule. The derivative of this will be 3. So it is 3 by 2 root 3x plus 1. Now substitute this 1 over here. It will be 3 by 2 root of 3 into 1 plus 1. That is equal to 3 by 2 root of 3 plus 1. That is 3 by 2 root of 4. That's 2 itself. 3 by 2 times 2. It's 3/4 or 0.75. So that's how we solve it. It's 3/4 answer. Both the cases will be 3/4. Even if you do in calculator, I'll just remind you how to do in calculator. All you need to do is press shift and the symbol over here, and now type the equation as it is. 3 alpha x plus 1. What is the x value given? That's the a value over here. It's mentioned as 1. The answer is 0.75 or 3/4. But you can't do the calculator method for this. It's a writing. So please do any of the writing method, this or even the power rule. See what I've just done. The same thing and get the answer in steps. Please do follow the same rule everywhere. Over here, you can take this to the power up. It'll be x plus 1, the whole power minus 1, and then use the power rule. Or you can use the formula over here and get it. A value is 2, so therefore they have changed the formula. Say it's A. This is the actual formula which I've written over here in the top two. So that this is the formulas you have to refer. Please do write the formulas. It's not mentioned here. It's very important to write these formulas and then start solving. Using 2.1, that is this formula over here. And if you're thinking of power rule, it's very simple. 6x, that's it. Now they are not given the a value. That means you have to use this x as it is and keep it in terms of x itself. So just do the power rule, it will be 6x. Yes. Here also 2x plus minus 2, sorry, 2x minus 2. And here it will be 3x plus 2, it will be 4x cube, 3x squared plus 2, it will be 4x cube minus 2a minus 4x, and so on. Please do try them by yourselves and then check for the answers. If you're doing the derivative method, take this power up, it will be x plus 1 whole power minus 1, and then solve it up. Same thing here, square root, we know 1 by 2 root x. So here, and then the chain rule. Don't forget the chain rule as well. Now we go to the last part of this particular question, that is to sketch the graph of the derivatives. Now, over here, let's see what they have asked. It is to use the graph of f to sketch graph f dash. F dash means we need to find the derivative. Always remember, let's try understanding by equation. What is this graph? It is a quadratic graph, right? Now, when I derive quadratic graph, it will be 2x. So the answer must be a linear graph. Is it true? Yes, it's linear. Now, what is this graph? This is a cubic graph, right? X cube. The answer when I derive it will be 3x squared. Just see the function over here. It should be a quadratic. It must be a quadratic graph, a parabola. That's true. Just let's go to the other ones also. This is to the power 4, I believe, because there's jumps, right? X to the power 4. So this answer will be x to the power 3. That is cubic. Say it's a cubic over here. This is a flat line, linear. So the answer will be a constant. Now imagine if you have say x, what is the answer? Or 2x, the answer will be 2, or a constant, okay, 1, like that. So the answer will be a constant. Here this graph is of 2x, so that's why it's a constant. Now similarly, yeah, the same thing, derivatives only. We will come to this also in a while. We will see all these. Now let's go back and see how to derive this graph. So we know the answer will be like this, but how do you exactly do that? Because you won't have any options, you can't guess and select it which will be the correct graph. Now you won't draw the exact graph, you have to just draw a sketch. If you look carefully over here, you can see a pattern. Wherever the graph is increasing and decreasing, there's a difference here. Let's see this first part, it's decreasing, right? Let's see till where it is decreasing. Here it decreases till this point, till this. So this is an important point. Now where is that? 0. So see, till 0, mark something, mark a point, okay? You will have like this, mark 0. Wherever it is decreasing, the part of the graph only will be before this, before. Where it's increasing, it will be over this. That's the concept. Now here this is a parabola. You should know by looking at it, the derivative will be a linear function and will just be like this, like this. Now whereas let's look at the next one. This has difference over here it increases over here, that is plus, minus, plus. Okay, what are the points? It's close to 0. Here it's not mentioned, but here they have mentioned it to be it's 0.5. Okay, this must be given in the question, but if it's not given, just take some distance away. So this much distance, mark that point, and this is another decrease to increase. Wherever it changes from increasing to decreasing or decreasing to increase, mark that point. This left side is plus, so what happens? It will be increasing, sorry, it will be not increasing. Here it will be above the x-axis, that's it. Here it was below if it's decreasing, above if it's increasing. Now wherever it's decreasing, it will just be below, okay, below. But let's do the increasing first. Here let's do the increasing first. So this and this point, right? Both sides, this is increasing, that much it must be above, this also must be above. Then it's decreasing, see, this is above, this is above, so these must connect like this, right, in the below. That's it. And we know this is a cubic, so the answer will be a parabola. That's how we can graph it easily. And the next one over here, again, let's look into where it's changed and increasing, decreasing till here, increasing here, decreasing here, increasing. So in the graph, what happens? We have to mark these 3 points, 1, 2, 3. It's decreasing, so it will be below, something like this. Last one, it's increasing, so it will be above. But what about this middle part? Here it's increasing, so it will be like this, but it has to come and touch here, because here again it's decreasing. See, this is plus, minus, minus, plus, minus, plus. If there is change in that plus minus, then it should come and touch over here. If it was no change, then it's fine, it would have gone something like this. Okay, if this was that, it would have gone. But anyways, now this is again minus, that means in the below, this will be the answer, something like that. It won't be accurate, but you can see this is the answer. These are accurate because they have just known accurately, they have put the derived equation and found the graph. But that's something. Now the last one over here will be a flat line. So why a flat line? Looking at this, you must understand it's a linear function. Okay, try to guess. This is x, but now the x will be 45 degrees. The slope is a little bit more, so you can see for every one distance of x, there will be at least 2 distance of y. So it's 2 by 1, that is 2. So it's 2x. The derivative of 2x is 2. So therefore the line is at 2. And now if you're thinking about increasing, decreasing, what's happening? It's only increasing. What do you do then? There is no point where it will change up and down. It's only increasing. So it must be any answer in the above part. This is only increasing. So it must be anything above the x-axis. Here, anywhere. Okay. Now if there is no value. It's just like this. Even if you put a line over here, yes, that's correct. At x, sorry, at 1, like this is also correct. Because they have not mentioned anything, you can't tell this is correct and this is correct. But if it was like this, then it should be anything down, okay? Line at the down, a straight line. And then over here again we need to find the derivative graph itself. I thought there was two types of problem, that is derivative graph and the function. Here only derivative, so whatever I just now told you, if you remember that, it's enough. Now let's look over here. What's happening? This one here, let's look at this. It's decreasing and decreasing. So these, you can see, will be below the axis itself. Now this one is very hard to graph, to be very honest. But let's look at each part of the graph. It's decreasing, decreasing here, decreasing, decreasing. All points are decreasing, so everything must be below the graph only. So there is like a thumb rule in such cases. So this, just do it like that. Whereas this one, it's decreasing, so it can't be above, just make it below. And this part is decreasing, just let it be over here. Whereas this part, instead of increasing, you have to just make it down. So this is it. Okay, just main concept is all these part of the graphs will be below when you derive it. That is the main part. Here now, this is a simple one. What if it's a constant? Now imagine this is a constant at 2, I guess. So what is the derivative of 2? 0. So there is no graph over here. Can you see that? There is no graph anywhere up or below. It is at 0 only. Can you see that? Why? Because it is derivative of any constant is 0. Doesn't matter what, it will be only at 0. Now till this point, make a hole because it's a hole. Now what about the next point? Here, there's one more thing which you must remember. Whenever you derive anything, even if it's a point or a hole, we generally take it as a whole itself. So that is one thing. Now the derivative of this, again, it's a linear function. It will be a constant, right? But it's what, increasing, so it is up. And it's like a 45-degree line. Its equation is x, so its derivative is 1. So at 1, okay, till here. This is a piecewise. Now this is again a parabola, but it's what? It's decreasing. So now, sorry, it's not decreasing. Till over here, it's increasing. This is plus. From here, it's minus. So this point is said to be 1. The part is up and the remaining part is down. Because we know parabola's x squared, the derivative will be linear function, 2x. It's a linear function. So it must be a straight line. But till this point, left side will be above, this will be below. That's the concept. That's how we graph these. And now again, same way, please do try them by yourselves and then check for the answers. Here also the same thing, what I told, decreasing, decreasing. So it'll be down. Here it's two linear functions, it'll be just two straight lines. But look at this. This is what? Increasing, decreasing. So this part is above, this part is below. I hope that is clear. Now look at this problem. Here I thought all were derivatives, sorry. There is a function also. Now here the derivative is given and you need to find the continuous function. What we did just a while ago, see in the previous problem, we were finding derivative, right? What we did now, we have to do opposite. Wherever the graph is above this x-axis, that means it increases. Wherever it's below, it decreases. Okay, now this is the concept, and this part over here, y-intercept is also important. Why? Because have you noticed y-intercept, wherever this point is there, where it touches, here it also touches. So there's some similarities we will see now in this problem. Here, this is the derivative. Maybe this is a cubic graph. When we find the original graph, it will be one more. In the sense, sorry for that. In the sense, now, if this is cubic, we should have the original graph to be x power 4. Because only when we derive x to the power 4, we will get x to the power 3, right? So the original function must be x to the power 4. That means it's like a parabola with undulations. So how do we do that? Let's look at the graph. It will be easier to understand. Here, this part is okay at 0. That's fine. But now, what is above the graph? Above. This part, this much is above the graph, right? Till here, it will be increasing. See this point, wherever this point. Again, I will remind you, you won't get accurate answers. It's just approximate. See, till this point, that's over here, it's always increasing. See, it's increasing, going up, up, up. Now, which part is below? All this part till over here is below, right? So till that part, see, till over here, it decreases because it's all below. Down, minus, plus. See, this is above. Above I'll write A, below I'll write B. A is all positive, B is negative. See, wait a minute. So yeah, from here. Above the x-axis is all increasing, that's plus. From here, this is the, it should match, but you know, it's not so accurate. But from here, it's going down. And over here, you stop. Again, it's above from year to year. So what happens? Where is that point exactly? From year to year, it again is increasing. Can you see that? It goes up. Then the last point is again below, right? All this is going down. So that's it. Now you don't need to do it very accurately because it's not possible to do accuracy like this. Just see where it's above and below. Those points, just mark it up. Okay. And then since this is a quadratic, I know cubic, then this will be x to the power 4. It's a even power graph. It will be a parabola, something like this. Now I know over here. See, then since it touches over here, I can come down till over here and then stay over here. Then little up till over here. Sorry, it should be like this. Up over here, positive, then down. Okay, it won't be accurate, but they just want you to know where are the graphs. So these are the important points, the touching points. See, these must be accurately plotted, and then remaining, it's fine, you know, if it's not very accurate. The same concept is used over here, so please make sure you graph them properly. Even over here, you can see, just make sure whatever is above the x-axis, if it's above, it increases. Till this point, what happens? It increases. Sorry, this is not this. This point and the turning point matters. See, whenever you see a point where it touches the axis, here, this is the turning point. Okay, now I recall, this is again turning point. This is the turning point. Now, what about this point? The one which is turning point here, that is basically the point 0 over here. Okay. And now remember what is going down, right? Whatever is going down. Sorry, above the axis. See, I'm also getting confused. A will be increasing. B will be all decreasing, minus and minus, because till over here it's all below. And again, A, it will be increasing. So make sure you understand this. Just try to get the grasp of it. And over here, again, you can try this, see the concepts, see where it is increasing, changing, and then you can accordingly graph it out. So that's how we basically do the graphs. Graphing is simple as long as you understand few key points, what happens where. So please make sure you understand this thoroughly and try practicing more problems and solve these problems by yourselves. It'll be much easier then.